Looks good.
Uh, okay, great. So yeah, this talk, or at least the first part of it, is going to be about JCO and browsers. We're going to start with just the JCO bit before Luke comes on and talks more about the browser bit, which he's gone over a little bit of actually already, very early in the day today. So for people who are maybe not familiar, I think many people on the call are, but just for those who aren't, this is a quick overview of the sort of WASM ecosystem for JavaScript. So it starts sort of, I've gone sort of lowest level first. So Starling Monkey here is essentially the wrapper around Spider Monkey that compiles to support guest components, right, that are written in JavaScript. So for maybe those who really aren't familiar, SpiderMonkey is a JavaScript engine, one that powers Firefox, and that code base compiles to WASM, but obviously doesn't necessarily implement everything that is needed for the component model and various other features. So Starling Monkey is a project that makes that possible. SpiderMonkey obviously is written in C++, and so Starling Monkey sort of wraps that and makes that available to the next sort of step in the toolchain, which is componentized JS. And componentized JS's job is to essentially take JavaScript code, and it offers a sort of user-friendly interface to taking some JavaScript code and adding it, or essentially loading it into Starling Monkey and making a JavaScript component out of that, single ES module. And just as a note, things are ES modules, so we're very ES module focused here. There's no like CommonJS or anything like that. One of the projects that's kind of important but less discussed is the Spider Monkey embedding splicer, which essentially manipulates the component, the WebAssembly component that you'd normally have with the embedded Spider Monkey engine, Starling Monkey engine, and adds or removes imports and exports as necessary, and facilitates the actual communication that occurs when you call an export or call an import. That happens to be written in Rust, so componentized JS is a bit of a mashup of Rust code and JS code. Then on top of that sort of middle layer is JCO, which actually calls down to componentized JS to do its componentization. So if you call JCO componentize, it actually just calls straight through to componentized JS. And there's a bevy of sort of supporting projects here that try to make it easier to work with componentizing, or basically components that have been created, and importantly to transpile components so that they can run in JavaScript environments that are not, and sort of use JavaScript environments as a WebAssembly host with support for the component model. So this means that you can take a component that was written in any language, Rust, Go, JavaScript, of course, and run it in any environment that has a engine that supports WebAssembly, a JavaScript engine. So that means browsers, and that means Node.js, for example. A quick run through the projects here. JCO is obviously the top level CLI project. That it's a Node.js project, but uses lots of different parts. So in this case, it actually uses some Rust code as well to access a lot of the upstream WebAssembly like tooling. And there is JCO Stud, which is a sort of amalgamation of useful utilities for when you're writing JS guest components. So this means, or writing for JS guests. So this means writing JavaScript components. It does useful things like adding a simple interface for like making web servers, for example. JCO Transpile is the key to doing the host into turning a JS component or any other component written in any other language into something that could be run on Node.js or in the browser. JCO Transpile is basically a way to take a component, and we'll talk about this a little bit more later, essentially break it down into WebAssembly that most engines support. So this would be sort of core WebAssembly, and then wire up the requirements of the component model such that you can run with just JavaScript and the core WebAssembly. JS Component BindGen is a crate that is written in Rust and helps to make basically JCO transpile possible. It includes a lot of it makes heavy use of the upstream WebAssembly tooling that's been developed by a lot of the people on this call, and makes it easy to generate essentially the binding and the glue code that makes a WebAssembly component run as essentially core WASM in many various JS runtimes. Another sort of small tool that is not very well known is actually we have a small chunk essentially of WASM tools componentized in JCO. This is something we've actually wanted to spread and sort of componentize more parts of Wasm Tools component, but right now I think this is the one place where this lives. And the last two are actually useful for components that are written in JavaScript, and they're actually post sort of componentization when a component is being run. So they are shims for the WASI interfaces that are present in Preview 2 and upcoming Preview 3. So this is a quick overview, again, of just how you take JavaScript and turn it into a component in the ecosystem as it stands today, right? So essentially, we build SpiderMonkey into a WebAssembly binary with P2 bindings built in. And again, that happens via StarlingMonkey. So StarlingMonkey is SpiderMonkey and more. We take essentially your input JavaScript and we build it into the StarlingMonkey WASM and essentially bundle it in there. And componentized JS splices interfaces, and in this case, I mean WIT interfaces. In the binary, we run a tool called Wiser to initialize and snapshot the WebAssembly binary. And then we pass, obviously, when you want to run the component to a runtime, right? And obviously, this runtime doesn't have to be JCO transpile. It can be Wasmtime. It can be any sort of component model compliant runtime. In this case, and in browsers, it's V8 or anything else, and in on servers, it's quite often Node.js. So one of the things that's changing now is we're adding P3 support onto various parts of the ecosystem. So obviously, one of the things I'm working on is P3 host binding. So this is basically integration of P3 and sort of new async functionality and interfaces into the host, right? And when I say host here, I mean JCO transpile. So you can think of the output of JCO transpile as a sort of generated host, right? That runs on, let's say, V8 below or any sort of WebAssembly supporting, or core WebAssembly supporting JavaScript runtime and glue code. So that's sort of those two things together come to build a host. So I'm working on the P3 host bindings for that. Till has started working on Rust bindings and essentially a sort of harness around StarlingMonkey that makes it, first of all, a lot easier to implement. Well, I'd say easier and safer to implement features. And along with doing that, implement features in Rust. And along with doing that, one of the things that sort of falls out of that is that Rust right now has great support for P3 on the guest side. So that makes, obviously, creating P3 a lot easier. Joel, who just gave his talk a little bit earlier, is working on componentized JS and notably sort of rewriting it to use WIT dylib, which was also mentioned earlier. And this is, I think, underappreciated because it's going to get rid of a sort of circular dependency that's actually always existed, which is that JS component BindGen is actually used in componentized JS, but it's transpiled. So it's a little bit circular there, and it can be really confusing for people who are new to the sort of setup. It's a little finicky sometimes. So thanks, Joel, for that. Along with that, we've got work ongoing, and a lot of it is exploratory but extremely promising for alternative runtimes like componentized QJS. So this is QuickJS, specifically QuickJS new generation, which is the sort of community project that sprung up around Fabrice Bellard's like original QuickJS project. And so that exploration is sort of a combination of with dilib and this QuickJS new generation project to see what it would look like to build a componentize that is not dependent on StarlyMonkey in particular, but uses a different sort of JavaScript engine on the guest side, right? So on the component side. I think this is really nice because it represents like a sort of point in the, let's say, the trade-off space between size and like how many features are supported, because obviously QuickJS has fewer features but also generates smaller binaries than something like StarlyMonkey with SpiderMonkey underneath it. And along with this, I've sort of covered it before. Till is working on essentially P3 guest bindings. So one of the things that, moving on from what you can sort of do and with the guests and how pieces of P3 are progressing, if we talk quickly about how a component runs in JCO transpile, I've covered this a little bit before, but basically it performs, or JCO transpile performs an unbundle of your component. So I call it, I have Wasm tools unbundle here, written because that's an actual command you can run with Wasm tools, the sort of upstream tooling, to take a component, break it apart into core Wasms, and those core Wasms will have imports and exports that are required to implement the component model. And the host has to obviously supply those imports and exports. In general, these steps sort of happen, imports need to be wired somewhere. Generally for a host like JCO transpile, the kind of sort of host and glue code that it generates, you need to walk the sort of Wasm instructions that are called from the core, from inside the core Wasm, and do something, right? Like, for example, if a specific instruction or a canonical essentially instruction is called that would do something like, let's say, a task return, or like something that would perform, like do something with a resource, for example, you would need to handle that in your host code. And that's what JCO transpile does, right? It adds code and sort of glue code that does the right thing when a certain Wasm or a component model intrinsic, let's say, is called. So it does these things. It generates this glue code. It outputs the core Wasms that were sort of unbundled, and then it adds stuff like support for JSPI for places where async behavior should occur, or whether the host has async behavior to expose to the component. This is actually kind of also underappreciated because there are a whole bunch of places where it makes a lot more sense to provide an async host implementation to a component, but obviously components need to have that wrapped before they can call that import, and JSPI is one way to do that. So thanks to Calvin, who also implemented this last year, if I remember correctly. So what's changing with P3 components? So that's all of that I've talked about up until now is what JCO does or does for P2. But in P3, how this changes is that we basically have more support for more intrinsics and more pieces of the component model that are required for P3. This generally plays out in like supporting new imports and supporting new kinds of exports that essentially unbundled components use, but it also extends to new kinds of intrinsics and instructions that are used in the Wasm, in the sort of core Wasms that are being that are defined or that are essentially unbundled. So this means that code that basically supports the glue code that is generated here needs to support doing everything a P3 compliant host would do, just like we had to for a P2 host. And so this means new kinds of sort of lifting and lower mechanisms, and new kinds of sort of intrinsics and state to manage that basically the host has to manage, or has to sort of manage in the same way as other component model P3 compliant hosts. In this case, the how JSPI is used is becomes a little bit different and slightly more complicated, because as async imports are now possible, one of the things that's happened a lot is needing to essentially thread and make sure that certain not only host imports but also some component exports are properly using JSPI, and sort of you can have a sort of call chain that makes more than you would think necessary for essentially invoking JSPI and wrapping component exports and host imports. So a quick look at sort of what's done and what's left. I think right after this, I'll show you a bit of the code and what this ends up looking like. But up until now, a lot of the work has been on semantics and trying to get the JCO implementation of the host as close to what is already working and working quite well, thanks to Joel and Alex's and Roman's hard work, and getting sort of JCO to be close to doing or working in a similar fashion to Wasmtime, and the P3 support that has landed in Wasmtime via the guests and also the host is pretty solid. So we try to follow that and also follow the spec independently to implement all the sort of features. So this is kind of a list of features of the component model in general, but we've gone through a lot of the sort of semantics around async tasks and subtasks, waitables, back pressure, etc. And right now I'm working mostly on support for streams. So this is, right now I'm sort of doing this sort of long tail of making sure that values you send through streams all get sent properly, lift and loaded properly, and there aren't any surprises there. And of course, I'm stopping short of writing a fuzzer, because I think that's clearly what we want here is sort of property testing, and this is what Wasmtime actually does. Very solid implementation there. But to avoid being any more late than I already am, we're gonna just we've just got a large list of functions that just we just try a bunch of different combinations. The fuzz work is likely far in the future. And after this, what we have left is futures, which are basically streams but simpler, with slightly different caveats, and P3 shim integration. Now, the P3 shim work is actually at one level already done, and an initial implementation is there, thanks to Tomasz for working on that. And we've written it in such a way that it should be simple to integrate, but it is just one of those things that we actually integrate it and sort of put the two pieces together once the sort of base level of sort of streams and features is done. And one note on why we have to do that is that P3 interfaces, so like interfaces to things like standard out, standard in, that are provided by WASI, are written in terms of P3 primitives, like streams, let's say, or features. And so there's while much of the shims stay the same, some of them will obviously have to change. So there's a little bit of integration work there. And in the future, at some point, threads should and will need to be implemented in the JCO transpile or JS host. Right now, we essentially pretend like we have one thread, essentially, and so tasks are not able to spawn new threads. And like for example, if a component tries to call the intrinsics that create, start a new thread or spawn a new thread, you just basically get a error thrown, right? So you just get a trap. And here's a little bit of what would be nice to have in the sort of far future. There's a lot of implementation polish that needs to be done. Part of the work on P3 was just sort of reorganizing and getting the code base into a shape that makes it easier for other people to contribute, which I think has gone well so far. Debugging, I think, has also been a sore point for some users, and also myself while working on it, because there's multiple layers, right? You can have errors that happen at the starting monkey layer, Slightly less at the componentized layer, but that's always possible. Of course, if you're dealing with a JS guest, like a JS component. And then you have issues that can happen at the host level, right? So you have all these different levels. And of course, when you're actually executing the component, knowing what's happening and which, like, for example, which intrinsics are being called, or which, like, at what point you've entered an import versus left it, et cetera, can be hard to debug. So one of the things that's, being a big part of this that I've been focusing on is this a new JCO debug flag, which sort of gives you essentially not quite a trace, but a sort of just logs essentially a lot of the internals of the JCO host as it runs. So it makes it very easy to debug. And of course, the usual, improving documentation and getting to better testing. So I wanted to jump in a little bit to something a bit more practical and show what the code looks like, right? So in particular, what sort of a simple P3 interaction looks like. So if we have this simple, and this is taken from a test inside the repository, so it is out there already and merged at this point, though there are more tests to write. But so if we have a Win interface that looks like this, and you just take something simple, like you want to, this test is written to take basically a list of values, a list of U32s, and return a stream of those very same U32s, right? So basically trivial. With a WIT like this, so importantly, you've got the stream of U32s coming out of there. And so in this case, in the JCO's case, we use Rust guest code for this because obviously we can't use JS guest code just yet. Really, the important part is down at the bottom. So you see the implementation for that get stream U32 function that was exposed by the world in the previous slide. You can sort of ignore a lot of the syntax here, but in particular, we basically just take the list of vals or U32s in the vector, and we just write them all back, right, after from an async task that we spawn. So what does that look like when you try and use it from a JCO transpiled component? So code here, there's this code is a bit sparse and sort of, I've deleted some stuff to make it clear, but most examples will look something like this. After you run JCO transpile, you get a folder with, as I've mentioned earlier, unbundled components. So essentially Wasm core modules and glue code, right? So the entry point of that glue code, you can import as an ES module from your code that's looking to use the component. You can also specify the WASI shim. So in this case, we actually add in a WASI preview 2 shim. In the future, this is going to look like a WASI P3 shim, but you can actually modify this import object that's generated to look like whatever you want, right? So ideally, you can have a shim that has both P2 and P3 interfaces and anything else you need for running different components that might be built against different, essentially targeting different versions. And so once you have your module and you've called this instantiate function, you have an instance, and on that instance is exposed the interfaces and functions that you wrote into the world or that you built into the component. So here we call that sort of get stream U32 function, and we basically just await on the stream that we get out of it, right? So we get, and this is also sort of compatible with async iterator as it exists in JS as well, but we do it sort of manually here, and we sort of await the values, and you do end up getting obviously the values that are listed there. So it looks quite I would say normal and kind of idiomatic for JS, and the one way that isn't implemented just yet, but will make it even more sort of clear and easy to use from the JS standpoint, is making sure we return sort of web platform and basically like sort of WinterTC relevant objects. So just like the built-in streams and readable stream and writable stream and stuff like that, so that it is much easier to use and sort of, let's say, familiar for people who come from a strictly JS background. So when can you use it? You can use it right now, but you're probably going to run into some bugs because there's still bugs, mostly again with just all the sort of combinations of things you can send in a stream, which is what I'm working on right now. And of course, if you try to use the future, they're not quite ready yet. So those are some of the places you'd mostly run into issues. At this point, sort of running tasks and running async imports versus exports is quite stable at this point. But of course, that's not all of it. We still need a lot of the sort of interesting usage of P3 host is going to be centered around obviously streams and futures. So releases to JCO are happening as this support improves. And so right now version 1.17.0 is out. And 1.18 is going to likely be out this week. And that would include improvements to stream support and hopefully, if we can get it, futures this week. So we'll see if we can hit this milestone. And I noted this earlier, but another word about P3 shims. So Tomasz worked on this. The test suite is independent, and this is a link for anyone who's downloaded the slides. You can click through and see them. And they should be current on the 0.30 interfaces because I think they were updated relatively recently, and I don't think there have been any significant changes since. And moving into the browser talk, this sort of second side of this, browser support is actually still experimental in JCO, mostly due to missing P2 shims that never essentially got implemented. And at this point, browser support for P3 shims are deferred to sort of post 0.30, lightly at this point, but high priority after sort of the Node.js shims that exist right now stabilize. So I'm sure people who love the browser are probably not very happy about browser support still being experimental, despite JCode being around for a very long time. And people have actually been stepping in from the community to help us implement some of the missing pieces. Of course, there's not a ton of, it's not unusable, right? But it's just not a host target that is currently well supported. For example, HTTP fetch, or basically outgoing HTTP or HTTP sort of outgoing handler was not well supported, and that's obviously something you'd want to do from inside the browser. So thanks to this GitHub user Dan Bopes, who stepped in to add this implementation. And so this is one of the places that if you are watching and you love JavaScript and you like WebAssembly, you want to get your hands dirty, there are lots of sort of low-hanging fruit left to fill in on both P2 and P3 browser shims. And this would directly affect and help anyone who's trying to run WebAssembly components in the browser with using the browser as a host. And that's it. So I'm happy to take any questions now. Thanks to all the contributors. There are way too many people to name. It's really difficult, but just across the ecosystem, a lot of upstream crates that we depend on, whether it's like Starling Monkey, JCO, or Componentized.js. It's really a team effort, and so it's great to work on this with everybody.
And thanks so much, Victor. We got time for about one question. And so we'll see who the lucky person is who gets to ask it.
And then we'll throw it to Luke to talk about the web. Or maybe
might have to push some of that to tomorrow. So got to be respectful of people's time.
I didn't have much to say other than this is very important work. Great job, Victor. This is so strategically important for, the browser is so important to WASM, and JCO is so important for the browser story for reasons I said at the beginning. So great job. Your work here had to span concurrency, which is already hard, Rust and JS and new features and make a bunch of things work together. So thank you.
Yes, this is all very, very, very exciting. And I still stand by all of this working really well in the browser is going to be the thing that makes it work really well everywhere. So fantastic work.